Okay, so yeah, let's start the lecture today. Um, okay, sorry, I forgot to raise. Okay. Uh, so today is a little bit tricky because I forgot to charge my phone last night. So actually, I think the situation might be that. Sorry, I have to erase that. So I think the situation might be that when there might be like abrupt stops after I do the lecture. So I'll see how far I can get. Okay. So yeah. Okay. Okay. It was. Okay. So bear with me. Okay. Okay. So okay, so let me just continue for the lecture. So I think last time I showed that this X is a Hausdorff space. Okay. Uh, oh, oh yeah. I think I left with one small part. Yeah, I think I left with a part where you have this gamma one acting on this R1 intersect this R2, is contained in the set where you take the union R in this gamma 1 PR intersect with the intersection of R in this gamma 1 QR. Okay. Okay, so let's see. Okay, so remember that we have this graph, right? So we have this graph. I think this is like QR, right? And then hold on one second. Okay, so we are taking these intersections. Okay, so okay, so this is the point y2. Okay, so remember, so this is the point y2, and then this is point y1. Okay, and then for this y1, what we do is that, yeah, so we take the neighborhood QR about y2, and then we take the neighborhood R inverse of PR of this y1. Okay, so this is like think of this one. It's like R inverse of PR, where PR is PR is the neighborhood around R of y1, such that these two are destroyed. Such that these wait, what are destroyed? Yeah, so for each R, right? So PR and QR, they are destroyed. Okay, yeah. So this PR and QR, they are destroyed. Okay. Okay, so okay, so if I take any element, okay, so if I take any element X in this okay, so if I take any element here, so that element can be represented as some element R in this R. Okay, so this is R1, right? This is like R1, and then this is like R2. Okay, so this element they both lies in R1 and also sorry. Oh, yeah. So it lies in some. Yeah, it lies in some gamma. It's some element R in this gamma 1. Let's call this R1 in this gamma 1, and such that it lies in the set R1 applied to this this big R1. Okay, so similarly, it lies also in this R2. So that implies that. So since it lies in this R2, right? So it must lie in this set. And then since it lies in this R1 times, since it also lies in some element R1 applied to this R1, therefore, let's see why. Okay, so since, okay, so we have the other relation. So that X be in this set R1 of this R1. So this implies that, so what is this R1? So this R1, so remember, so we call that this R1 is equal to V1 intersection union or intersection of R in this R1 of R inverse of PR, right? Okay, so why it lies in the union of all this PR? So, it suffices to show that it lies in one copy of PR, right? So why it lies in one copy of PR? So, okay, because we know that this R is in this R1, right? So, and then, okay, so this implies that there exists a element, let's say x prime in this R1 such that x is equal to R1 of x prime. Okay, so okay, so since this x prime lies within all this set, right? So this implies that, yeah, so this implies that this x is in, okay, so what does it imply with this one? Because this R1 is in this gamma 1, so this lies in this R1 inverse of P of R1. Okay. Okay, and then it lies in what? Oh, sorry. This is x prime, yes. Okay, so this implies that this R1 of this x prime lies in P R1, right? And then this is what? This is just x. Okay. Okay, yeah. So this is true, okay. And then, so why is it empty? So basically, okay. So the idea is that if you take, so each PR and QR, we know that they are empty, right? Yeah, so I'll leave it to you to figure out. Okay, I'll leave it to you to figure out. Okay. Yeah, so namely the idea is that if you take any element x here, right? So x in these two sets means that x in here, x in here. If x is in here, then x in one of these PR. So yeah, so that's a contradiction, okay? Because you can have this x lies in PR while also lies in this, at the same time also lies in this QR for all R. Wait, no, sorry, hold on. it's right. Yeah, it's right because they are destroyed, right? We cannot have this like x less in PR while also less in this QR for any, yeah. Yes, okay. Yeah, so this is true. Okay. Alright, so okay, so therefore this shows that this x is Hausdorff, okay. And then, okay. Okay, so moreover, okay. Let me check whether there's still power. Okay. Okay, good. Okay. Okay, moreover, since this gamma is surjective, okay. Okay, so let me continue. So, moreover, okay, so since gamma is a surjective local homomorphism, X is also connected. Locally simply connected. And locally compact. Okay, so yes. Okay. X is also connected. Wait. Why this X? Okay. Locally simply connected. Locally compact. Okay. Let me think. Okay, so we know that this. Oh, yes, because this gamma is continuous, right? So continuous image of a connected set is connected. So therefore this X is connected. Okay. And then this yeah. Okay. And then if since gamma is a surjective local homomorphism, locally simply connected. Okay, so why is the locally simply connected? So yeah, so let's draw. So here, okay, so this is x, so this is x student, and then this is x, and then, yeah, so, and then, so this is like gamma, and then, local homomorphism, locally symmetric connected. Okay. Okay, so basically the idea is that, so here, okay, I think the idea is that if we pick any point, so for any neighborhood u of this x, right? Sorry, b, okay. And then pick a base point, let's say x naught here. And then we pick a, we pick a evenly covered set, okay, u, right? So, and let's consider the set v intersect u, and then we take the inverse image. Then becomes like let's say take one copy of inverse image. Let's say let's call this w. Okay. And then yeah, sorry, I use the w to be defined as this v intersect u. Okay, so this is like v here. And then okay, this is u. Okay, and then let's pick a w tutor, like one component of this disjoint union. This is w tutor, and then we'll pick a, let's say, corresponding inverse image y naught. Okay, and then since this gamma is since this x tilde is locally simply connected, right? Therefore, we can pick. Yeah, we can pick a simply connected set, simply connected neighborhood that is that inside is w tilde, right? So let's call this let's call this A. Okay, let's call this A. Maybe let's say A tilde. So A tilde is simply connected, that's inside W. Okay, also open, and then okay, so I want to show that this, if I do the projection, does this A tilde, so that A to be the projection of A tilde, okay. So let's draw this A here. Okay. So this A. Okay, so we want to show that this A is simply connected, right? So okay, so Okay. Loop upstairs and then okay. Okay, so I think um, okay, I think the idea is that um, so we want to show that this pi one of a x naught is equal to it's trivial. Okay, so so that is R from okay, so let R be a loop. With space point x naught. Okay, so because this gamma is a continuous map, so you compose this continuous map. It is also continuous, right? It's also a loop based at this y naught. Okay, and since this is semi-connected, so you can homotopy it to the base point, right? And then this homotopy will give you a yeah. Let me try to write out base point x naught, and then okay. So let's see. So this is like from A to B, from A to B to this. So this is like the curve gamma. Okay, and then sorry, R. So R composed with. Oh, sorry. So I want to say gamma restricted on is a composed with this R is a loop. At y naught. It's a loop in respect to the. Oh, sorry, A to the. So this implies that yes, right. So there is a 1.